All right, I'm working a review on rationals. This section is graphing. It asks us to graph f of x equals 2 over x minus 1 by using the x-intercept, the vertical asymptote, horizontal asymptote, any holes, domain, and the y-intercept. So the first thing that I'm going to do is the vertical asymptote. So vertical asymptote, the denominator cannot be 0, and so x minus 1 can't be 0. So if I add 1, x cannot be 1. So the vertical asymptote is at x equals 1. So I'm just going to sketch that over here. So x equals 1 is right here. So we just have this vertical asymptote at x equals 1. So I'm drawing this dashed line to show that we cannot cross it. All right, next I'm going to do horizontal asymptote. There's nothing on top, and there's x on the bottom, so that means our horizontal asymptote is at y equals 0. That's just something you have to memorize. You can look at the videos on horizontal asymptotes if that's confusing. So I'm drawing a dashed line at y equals 0 to show that our graph cannot cross at 0. All right, a hole only happens when something or a factor crosses off on the top and bottom, so there are no holes here. So let's make a t-chart. So I've got x and y. I like to put my vertical asymptote in the middle of the t-chart. So here our vertical asymptote is at 1. And then let's go 2 steps backward, 2 steps forward. So let's plug in 0 and -1, and then let's also do 2 and 3. We know at 1 we get an error, or it's undefined at 1. Sorry, let me skip that over. All right, here if we plug in 0, it'd be 2 over 0 minus 1, so that would give us a -2. If we plug in a -1 for x, it'd be 2 over -1 minus 1, so that would give us a -1. If you can't see what I'm doing, I'm plugging in this column for x. All right, then I plug in 2. 2 over 2 minus 1 will give us 2. 2 over 3 minus 1 will give us 1. So now I have 1, 2, 3, 4 points to graph. So -1, -1, 0, -2, 2, 2, and 3, 1. So it's never going to cross the asymptotes, but it's going to get super close. All right, we could have answered x-intercept and y-intercept differently, but if you look at the chart, if you notice x is 0, y is -2, that means that our y-intercept is 0, -2. X-intercept, if you look at the graph, because we have this horizontal asymptote at y equals 0, there is no x-intercept. We can never cross this asymptote right here, so there's no x-intercept. And then domain goes from left to right. We hit every single number because of the arrows, but because of this asymptote, we have a gap at 1. So we hit everything until 1 and everything after 1, left to right. So the way that you'd write that is -∞, comma 1. We use open parentheses because we're never going to get to infinity, and then we're never going to get to 1 because of the asymptote. Union, which you use if you're combining two sets. And then +1 continues, open parentheses because we never reach there. Let me put an arrow here. Comma, +∞, because we're going to the right. Open parentheses because we'll never get there. All right, it says sketch the graph of the following rational function, f of x equals x squared plus 4x plus 3 over x squared minus x minus 2. The first question asks for the simplified form. So to simplify this, we need to factor. So I'm just going to do that right below. Top, there's 2 parentheses. X times x. We need to multiply to get 3, add to get 4, plus 3 plus 1. On the bottom, 2 parentheses. X times x. We need to multiply to get negative 2, add to get negative 1, minus 2 plus 1. Because there's plus 1 on top and on bottom, we can cross those off. So the simplified form, I'm just going to write into that blank, would be x plus 3 on top over x minus 2 on bottom. All right, the x-intercept is where y is 0, so I'm going to go ahead and draw that in the parentheses. Y will be 0 when the top is 0, and so we're going to look at the simplified form, so we're going to set x plus 3 equal to 0 and solve. So minus 3, we get x equals negative 3. So my x-intercept is negative 3, 0. All right, vertical asymptotes happen when the denominator equals 0. So I've got x minus 2 cannot be 0. Add 2. So x cannot be 2. So I've got a vertical asymptote at x equals 2. I'm going to go back. I'm actually going to graph negative 3, 0. And I'm going to graph a vertical asymptote at 2. Just do it as I go, which I forgot. All right, horizontal asymptote. You're looking at the original problem and at the leading coefficient. So on top, I've got 1x squared, and on bottom, I've got 1x squared. The x squareds are the same, so I'm just looking at 1 over 1. So my horizontal asymptote is going to be y equals 1. So let's go ahead and draw that too. So our graph will never cross either of these asymptotes. Great. Okay, so holes. Holes happen when we cross off something on top and bottom. So right here, we've got x plus 1 can't be 0. Subtract 1. We've got a hole at x equals negative 1. We'll graph that later. Let's do domain later. Y-intercept is where x is 0. So we'll plug in a 0 for x. If I do that, we can look at the simplified form, 0 plus 3 over 0 minus 2. So we're going to get negative 1.5. Let's go ahead and graph that. 0, negative 1, negative 2, so right in between. We can kind of see the graph starting to form right here, but let's make a t-chart just to be sure. So I'm going to scoot the paper over and make a t-chart over here. So I've got x and y. Some points to put in my t-chart. I have an x-intercept of negative 3. I've got a y-intercept that's at 0. Vertical asymptote at 2. So I'm going to go one step past, so negative 4, negative 3. We already know this gives me a 0. Negative 2, negative 1, 0. We already know gives us negative 1.5. And then 1, 2, we know already gives us an error. And then let's go a couple steps past 2, 3, 4. So what we're going to do is we're going to plug in all of these x's into our simplified form. So I'm going to take this whole column and plug them in for x plus 3 and x minus 2. I'm going to go pretty quickly through filling out this table, but you can always slow the video down if you need to. All right, so I'm going to graph these points. Again, I'm going to go kind of fast, but you can always slow it down if you need to. Really quick, I meant to talk about this. This right here was our hole. So instead of drawing a filled in circle right there, we're going to do a hole. All right, we're going to connect the dots. Just make sure you leave the hole open. We're never going to cross this asymptote. And there we go. And then never cross this asymptote. And there we go. All right, last thing we need to answer is the domain. We probably could have answered it earlier, but looking at the graph's a little bit easier. Left to right, we go all the way up until this hole. Then we have a break, and then we'll go until the asymptote, break, and then continue to infinity. So what that looks like is we start at negative infinity, we stop at the hole, we continue until the asymptote, then we continue from the asymptote all the way to the right, so infinity.